All right, today we're going to tackle a really big idea in system design, the CAP theorem. But don't worry, we're going to make it super simple by talking about one of life's most critical systems, pizza delivery. Okay, let's get into it. Yeah, I know. It sounds a little weird, right? But believe it or not, the answer to this question reveals a fundamental rule that runs everything from your bank account to your Instagram feed. The tough choices a pizza chain has to solve are pretty much the exact same problems the engineers at the world's biggest tech companies are banging their heads against every single day. So, what's the deal here? Well, it all comes down to a fundamental rule for any system that's spread out across multiple locations, whether that's pizza shops or massive data centers. And this rule is called the CAP theorem. So this idea comes from a computer scientist named Eric Brewer way back in 2000, and it's basically an unbreakable law for any distributed system. Now I know, consistency, availability, partition tolerance, it sounds like a real mouthful, but stick with me because our pizza chain is going to make all of this crystal clear. Okay, so picture this. You've got a pizza company, right? It's got shops all over the city. Each shop is like one node in a bigger system. Now, the CAP theorem says this pizza empire of yours can only promise 2 out of 3 things about its service at any given time. So let's break down what those 3 things actually are. All right, first up, C for consistency. All this means is that everyone sees the same, correct information at the exact same time. So in our pizza world, if the main office decides to roll out a new Volcano Supreme pizza, a perfectly consistent system means, bam, every single location's menu updates instantly. No confusion, no mistakes. The menu is just correct everywhere. Okay, next is A for availability. And this one's super simple. The system is just on. It works. When you call the pizza place or you open their app, you get a response. You don't get a busy signal, you don't get an error message. It's available to take your order. Period. And last but not least, P for partition tolerance. Now, partition is just a geeky way of saying there's a communication breakdown, right? So imagine a big storm rolls in and knocks out the internet connecting one pizza shop to headquarters. Partition tolerance means that little shop can still keep taking orders and slinging pizzas for the local folks, even though it's totally cut off from the main network for a while. So there we have it, the big 3. Consistency, availability, and partition tolerance. C, A, and P. And here's the kicker, the whole point of the theorem. Eric Brewer proved you can have C and A, or you can have C and P, or you can have A and P, but you can never, ever, ever have all 3 at the same time. You've got to pick. You're forced to make a choice. Okay, now this is where it gets really interesting in the real world. Because let's be honest, in any system that's spread out over a network, things are going to break. Connections drop, servers fail. It's not a question of if, it's a question of when. So you absolutely have to design for partition tolerance. It's not optional. And that simplifies things a ton, right? Because it means the real choice, the one every single system designer has to make, is between consistency and availability. So that really boils everything down to 2 main flavors of systems. You've got your CP system, which chooses consistency over availability. It would rather just shut down for a minute than risk giving you bad data. And then you've got your AP system. It does the opposite. It chooses availability over consistency. It will do whatever it takes to stay online for you, even if that means the information it's showing is a little bit stale. So let's see this in action. Our pizza chain decides to be a CP system. Consistency first. A network line goes down. Now, the local shop can't be 100% sure it has the latest, most up-to-date menu. So to guarantee you don't accidentally order a pizza that was discontinued 5 minutes ago, what does it do? It just stops taking orders. It puts correctness above all else. Okay, but what if they went the other way? What if they were an AP or availability first system? That same storm hits, that same communication line goes down. But this shop's #1 priority is to stay open and serve customers. So it'll gladly take your order based on the last menu it downloaded, even if that summer special you just ordered was actually taken off the menu an hour ago. It prioritizes being available over being perfectly in sync. Okay, so the pizza analogy is great. It gets us pretty far. But how does this actually play out in the apps and services we use every single day? Let's take a look at how these massive trade-offs are made out there in the wild. And I promise, once you see it, you'll start noticing it everywhere. All right, first example. Think about your bank. You're at an ATM, and suddenly there's a network glitch, a partition. The ATM is cut off and can't be 100% positive what your account balance is. What choice do you think the bank is going to make? Consistency or availability? You bet they choose consistency. every single time. And we should all be pretty happy about that, right? You would much, much rather see a system temporarily unavailable message than have the ATM give you the wrong balance. For a bank, the data has to be perfect, so they will always sacrifice availability to make sure it's consistent. Okay, now let's flip the script completely. Think about your favorite social media app. You're scrolling through your feed and boom, another network partition. The app can't grab the absolute latest up-to-the-second posts from all your friends. So what does it do? It picks availability for sure. It's going to keep showing you the content it already has, even if some of it is a few minutes old. And why? Well, because seeing your friend's cat picture from 5 minutes ago is a way, way better experience than just staring at a frustrating error page. For social media, being online and responsive is everything. And what's really cool is that this isn't always a single decision for a whole company. Take a big e-commerce site. When you're just browsing, clicking around, they're all about availability. It's better to show you a product that might have just sold out than to show you a blank page. But the second you hit that buy button, the system flips. It becomes all about consistency, making absolutely sure they don't sell that one last item to 2 different people at the same time. So there you have it. We went from this complex computer science idea to a simple pizza delivery problem, and then right back to the real-world tech we use every day. So what's the big takeaway here? The CAP theorem isn't just some abstract theory. It's a super practical tool for making really important design decisions. So really, when you're thinking about any kind of system, you can just boil it down to those pizza delivery questions. 1. Is it more important that the menu is always 100% correct? That's consistency. 2. Is it more important that the restaurant is always open for business? That's availability. And 3. What's your plan for when the phone lines go down? That's partition tolerance. Answering these simple questions forces you to figure out what really, truly matters. And in the end, it really all comes down to this one scenario. Your system is partitioned, a network failure has happened. You have to make a choice right now. Do you show your users an error message to make sure everything's correct, or do you show them potentially outdated information just to keep things running? The CAP theorem doesn't give you the answer, but what it does, brilliantly, is it forces you to ask the right question.